Good evening. In Antoine de Saint-Exupéry's Little Prince, the narrator and the little prince find themselves in the desert, in need of water. The well that they find provides them not only with the water that they seek, but also with spiritual nourishment, the unseen beauty that is invisible to the eye. Both the tangible and the intangible are what makes the desert beautiful to us as humans. It's a fundamental part of the human condition. Today, I would like to talk about the first humans who came into the Australian desert. What they found there was not only a well, in this case a lake, but also fertile ground for spiritual expression. I would like to talk about the tools that we use to learn about how people adapted to life on the world's driest inhabited continent. Professor Hublin has already provided us with a very eloquent and overview of the peopling of Australia, but I'd just like to remind you of the context which we're looking at when we're starting to look at something right at the far end of the world in the Australian desert. There were two major human dispersal events, both of which began in Africa, but only one of them managed to reach Australia, that of our own species, of Homo sapiens. In that respect, the human history and prehistory of Australia is a much simpler one to look at, but as Professor Hublin has demonstrated, it's not so very straightforward, and we don't have a great deal of information. Part of this lies in the fact that Australia is very isolated. And the reason why we only have one species of human coming into Australia is also because it's isolated. Here you see the map of Australia and how it sits relative to Southeast Asia. And here we have the map of the Southeast Asian continental shelf as it would be exposed during the ice ages when the sea levels were much lower, and the Sahel shelf, which links New Guinea, mainland Australia, and Tasmania, where my ancestors were transported 200 years ago, just for information. If we look a little more closely, and Professor Hublin has also given us an introduction, so I don't need to go into so much detail, but there are two major open ocean passages between Sunda and Sahel. These are known as the Wallaces and the Weber lines. This is because in the 1900s, when the scientists were moving around here, they noticed that there were some major biogeographical differences between the Sunda area and the Sahel area. Wallace came first. He was a pen friend of Darwin. And he noticed that there's an area of open ocean, some tens of kilometres wide, in between Bali and Lombok, in fact. If any of you go there for holidays, it's a very nice place to go. But what they found was that the flora and fauna on the eastern side was quite a lot different to that which was found in Southeast Asia. Then Weber came along. He was a German, so you can see my career trajectory is sort of following this history. And he actually noticed that the differences in biogeography and flora and fauna were actually much greater in between Sahel and this line here. And there's a good reason for that. And that is that there is almost 100 kilometres, depending on what the sea level is doing, 100 kilometres or more open ocean, whereas this is only a few tens of kilometres. On the Wallace's line, you can actually see Lombok from Bali. The Weber's line, there is too much open ocean. You cannot possibly tell that there is land on the other side of the Weber line. So we can understand why the flora and fauna might be so isolated and might be so very different on the Sahel side compared with Wallacea and compared with Southeast Asia. If we go back to that very first dispersal event, it does have relevance for our region. We do know that Homo erectus reached the Indonesian island of Java, over here, some 1.6 million years ago. But we don't have any paleoanthropological or archaeological evidence which suggests that Homo erectus managed to cross the Wallace's line. It looks like the story stopped here. Very recently, in the last couple of months actually, there was found a fossil on the island of Flores, which is in this transition area of Wallachia. And it was found to be around about 1 million years ago, 1 million years old. We're not entirely sure what species of human this is and how this species of human relates to the dispersal event from Homo erectus, or the timing, indeed, of the arrival of this species of human on Flores. But we do know that it was there. This species, however, has not been found in Sahel. So it's safe to assume that this species never managed to cross the Weber line and reach Australia either. Then we also have another smaller species of Homo, the hobbit, which most of you will be familiar with, which we know lived on the island of Flores as well until about 60,000 years ago. There was a correction in the chronology recently. We also don't really know what the heritage of this species is. We don't know whether this species derived from this older 1 million year old fossil or not, but we do know that it looks like their migration stopped here at Flores. They never managed to cross the Weber line. In this respect, humans are special. We're special anyway. But we are special for this reason. Then we have the dispersal out of Africa of modern humans. And modern humans, our species, managed to cross both Wallace's and Weber's line, and they appear to have reached Australia by about 50 to 60,000 years ago. The archaeological evidence suggests that they reached Southeast Asia. They reached the Sunda area by about 80,000 years ago. We're starting to get the first indications and dating from archaeological sites which suggest that they reached at least northwestern Australia and parts of New Guinea by about 50 to 60,000 years ago. And we know from Lake Mungo, and I'll go into greater detail during this talk, which is down here, was reached by at least 42,000 years ago. This is a fair amount of ground to cover. So it's a pretty impressive effort that they managed within about 10,000 years to cover 3,000 kilometres of open desert as opposed to open ocean. If we look at the conditions around the timing of the arrival of people onto the Australian continent, so 50 to 60,000 years ago, we can calculate what the sea levels were doing at that time, and this is based on a record from the island of New Guinea. And we can calculate that there was 90 kilometres of open ocean between Timor in the Wallachia area and Australia, this northwestern entry point. So they must have covered 90 kilometres of open ocean. They must have known how to handle boats. They must have had a maritime culture. Now, the best evidence that we have for this maritime culture comes from Timor rather than from Australia. But it shows that around about 40,000 years ago, when we look at the archaeological food remains, they were eating about half fish derived from the coastal regions, so very easy to catch, and about half of the fish that they were eating were they were pelagic species. They were coming from the open ocean. So we know that 42,000 years ago on the island of Timor, people were using boats to navigate out into the open ocean, to come back to the islands that they were living on, and to eat the fish that they caught. So it stands to reason that it's the same people who were responsible for covering that 90 kilometres of ground, reaching the Australian continent, and coming there again so that we had enough of a viable population to then populate the rest of Australia. But what they found there was quite a lot different to what they were used to on the Indonesian archipelago, those tropical islands. 50% of the continent of Australia is desert. Australia is the driest inhabited continent on Earth. The Aboriginal people were hunter-gatherers, but we also know from the archaeological record and also from the paleoenvironmental record that they immediately had an impact on the environment. And I'll just show you a couple of examples before I move to Mungo, because the timing of this is actually really very important. You've seen this graph already, but it provides us with a good indication of what kinds of paleo-environmental changes were taking place around the time that humans were arriving on the Australian continent. This example comes from a crater lake, a volcanic crater up in the northeast of Australia in Queensland, near where my uncle and aunt live. And they looked at the pollen, so they were able to reconstruct what kind of vegetation was growing in the area, and they looked at the charcoal. They were able to look at the frequency of fire in the area. And what they found, we're in the tropics here, what they found was it was dominantly rainforest until around about 42,000 years ago. At the same time, we have a big peak in charcoal. This shows that we had a higher frequency of fire occurring in the landscape of 42,000 years ago. Now, if we look at other climatic records from the region, we don't see anything special happening. It's not particularly dry, it's not particularly hot. So why is there suddenly this major ecological change? The most parsimonious explanation is that it's people moving into the landscape and using intentional burning to encourage the growth of grasslands. If you encourage the growth of grasslands, you expand the habitat of the grazing animals like the kangaroo that the Aboriginal people so like to eat. So it's good for, as an Aboriginal hunter-gatherer, to have more grassland. So since the timing coincides very closely with the arrival of humans onto the continent, it's safe to assume that most likely this ecological change was because of humans. Another interesting thing happened around about 40,000 years ago. We've already seen the megafauna which existed on the continent of Australia, and we've seen what kinds of species they have. There was a giant marsupial wombat bear type creature called the Diprotodon, size of a Volkswagen Golf, a Käfer beetle. I'm sure there's a French equivalent, I just can't think of it right now. And we had giant kangaroos that were 3 meters tall. We had ferocious lizards that were 6 meters long. You wouldn't want to meet one of those. But the fossil record indicates that almost all of these species that were above 45 kilos in weight disappeared around about 40,000 years ago. Unfortunately, at this point, we've got no direct evidence which shows that people were hunting these animals or that people were seeking out their young or destroying the habitats. We just don't have any concrete evidence, but it's very interesting that the timing coincides with the arrival of humans on the continent. 42,000 years ago, we also have the oldest evidence of people in the southeastern corner of the continent. This area is known as the Willandra Lakes. It's a system of now dry lakes which spill over into one another. They're fed by a creek known as the Willandra Creek, and they slowly sequentially filled up. Lake Mungo is an overflow lake, so it's sort of an afterthought, but it wasn't an afterthought to the Aboriginal people living in the area, I can tell you. But the spectacular thing about knowing that the people reached Mungo by 42,000 years ago is its location. It sits about 3,000 kilometres, as the crow flies, as we would say in Australia, from the likely entry point. So within 8, 10, 15,000 years, people managed to cross the desert somehow in order to reach Lake Mungo. And this is where our well idea comes in. Now, you've already seen this map, but it's very important to recognise how much of a role water plays in the desert. In order to reach Lake Mungo, we've got very large areas which literally do not have any surface water. There is no coherent drainage across this entire region here, no rivers whatsoever. In this area, we do have rivers, but they only flow in wet years. So what Professor Bird did a few months ago was look at or map the density of water in the landscape, and from that to deduce what route people were likely to take in order to reach the desert of Australia. And it looks like it wasn't a linear sort of migration across the landscape, and that stands to reason if water is important for your sustenance. But we also know that they reached Lake Mungo very quickly. So this looks like it was the most efficient and effective route. And the distance to water played an enormous role. So 42,000 years ago, it wasn't just a couple of stone tools in the landscape. 1969, my master's professor, Jim Bowler, was doing his PhD actually, wandering around the landscape of the Willandra Lakes, trying to look at the history of desert expansion and contraction in Australia. Up until that point, we hadn't really got a very good grip of what was going on in the environment in the past in Australia. And the Willandra Lakes seemed like a good place to look. After all, it's a series of lakes. They're sitting on the edge of the desert. You have a good record of the lakes filling and drying, and this can give us an indication of the expansion and the contraction of the desert with time. As it happens, he stumbled on this. This is the Mungo 3 burial, and we've already seen this, but it was also highly significant because Professor Bowler, or young Mr. Bowler at the time, realised that this burial was sitting very low in the stratigraphy. At the time, this was very important politically because at the time, the governmental viewpoint was that Aboriginal people had not been in Australia for more than a couple of thousand years. But Professor Bowler, knowing as a geologist that this stratigraphy must have been really quite old, tens of thousands of years perhaps, that substantially lengthened the amount of time that Aboriginal people had been living on the continent. Now, this was exactly at the same time that the Aboriginal people gained citizenship to Australia and gained the right to vote, and there was a gathering impetus to try and get land rights. And up until that point, land rights had been turned down on the basis of the fact that they hadn't been there for very long. Well, this turned everything on its head. So it was really important politically for human rights in Australia as well. It was a very exciting time, scientifically as well as politically. Now, what we've seen from this burial, it was covered in ochre, and ochre is something which is very hard to find in this part of Australia. They must have walked about 100 kilometres or more in order to find this ochre. So in order to cover your dead relation head to toe in ochre, in order to bury them, must have required a huge effort and must have required a level, perceiving this burial as something that's highly significant. So what we can say from this burial is that people in the desert at Lake Mungo not only reached the area by then, but they'd also developed spiritual traditions by this time, just like the Little Prince. We also have evidence on the lake bed, on the lake floor, of footprints moving across the landscape. Now, these have been dated to about 20,000 years old. But what's also interesting, these are some of the descendants of these people. What's also very important about this site is that analysing the footprints, they found that there was a one-legged man who was being helped. So people were helping this one-legged man, this disabled man, to move across the lake floor. So what we can also say about people at Lake Mungo is that they helped the disabled, they helped the people who needed help. They had a sense of humanity, a sense of charity. So that makes Mungo another special kind of place. Lake Mungo looks like this nowadays. It's a dry lake bed. Here it is. On the downwind, the eastern shoreline, we have this moon-shaped dune feature. It's a shoreline dune. We call it a lunette. I understand that also means spectacles in French, so my apologies. It's a geomorphic term. But it's also a very important area because in the desert of Australia, generally, we have very little sediment, which preserves information about past environmental change. Now, these lunette dunes, which form on the downwind side of the lake, actually provide us with some of the richest and most continuous, even though they're not at all continuous, archives of past environmental change. Because we've also got this amazing archaeological record, this provides us with an unparalleled opportunity to reconstruct the interactions between people and their environment through time. So for this, I need to move over into the realms of geography and geology and give you some kind of example of how it is that we try and understand the past by looking at the sediments and at the landscape. Now, here I'll give you a few examples of different kinds of conditions which result in different kinds of sediments being deposited within our lunette. So if we've got a lake full stage, we've got wind driving across the lake and forming waves, we have the formation of a nice sandy beach, just like you would along the coast. And when there's enough sediment, that sandy beach then forms a dune along the shoreline. We call this a sandy lunette dune. The kinds of sand that we see is nice and rounded because it's been abraded by the waves. It doesn't have a lot of clay in it, it's very nice and clean, and it's mostly quartz because we're dealing with a very old landscape. Of course, people are living in this landscape. They're burying their dead, they're barbecuing their kangaroos, sometimes they're cooking fish. And once this lake starts to retreat, we start to get the erosion and partial removal of the sediment, but also of the archaeological remains. So here we have our partially removed burial. Man's legs have disappeared. Sorry about that. So now we've got our drying stage, a stage which is also known as the saline stage. Now we've got the exposure of the old lake bed. And the old lake bed has a lot of fine clay in it. It also has a lot of salt in it because it's the desert. We've got a great deal of evaporation taking place. Now, during this stage, and the exposure of the lake bed facilitates a process known as efflorescence. Now, this is a reaction between the salts and the clays to form sand-sized particles of clay. And what this means is that the clay can then get transported, just like sand would, onto the dune. So what we then get is a saline clay dune. Again, we've got people moving around the landscape, burying their dead, barbecuing their kangaroos. And following this stage, we then also get partial removal of the archaeological and the sedimentological record. A third stage, which is also possible, and in Lake Mungo's instance, this is very common after 15,000 years when the Willandra Creek stopped flowing and the lakes were completely dry. We get the formation of soils over the top, and sometimes these soils are what is known as accretionary, so they can form a blanket over the top of the existing sediment, and sometimes they're what's known as in situ, so they actually form on these partially removed plinths of the old dune. In any case, people are still in the landscape, people are still leaving their traces in the landscape, barbecuing their kangaroos. They can't barbecue any fish anymore. But this is the kind of, we need to be aware of these different situations resulting in different kinds of sediments being deposited in our lunette. And from that, we can then start to match up the archaeological traces that we're finding in those same units. What's important here is that if you're looking at a past environmental or an archaeological archive, this is the place to look. You look on the lake floor, you're not going to find a great deal, so this is the best place to look. Lake Mungo is important because it's a well in the desert. It provided, when it filled at least, it provided water and it provided a habitat for people. But it's also important to recognise that it filled and it dried as a result of rainfall in the highlands of Australia about 1,000 kilometres further to the east. So when you're thinking like a geologist like myself, you have to bear in mind that when those lakes were filling and drying and you're trying to reconstruct past environmental conditions, you're looking at two things. You're looking at when the lake was filling and drying there on the spot, and this provides a habitat for people, and those people are responding to what's happening in the lake. But then if you're trying to reconstruct climate and you're looking at a full lake phase, you're looking at climate which is happening 1,000 kilometers further to the east. So I need to bear that dichotomy in mind. The archaeologists less so, because people are focused on the ground. So what we're doing in this project is investigating long-term landscape change and the human adaptation to that change by systematically integrating both the archaeological and the geological evidence. And we're doing this literally by foot. So here is an example of 3 different stratigraphic units, all within about 1 vertical metre. Here we've got a nice red unit which represents lake full phase, and then on top of that we've got a sandy unit which is another lake full phase, but it's got a different kind of sediment source, so it's likely to be a different event. And then on top of that we've got very clay-rich material, so this is our lake drying phase. I'll get to the archaeology in a minute, I promise. But it's important to bear all of this in mind with a landscape like Lake Mungo, because you've got to look at the large scale. We're talking about a lunette which is something like 35 kilometres from north to south. Of course, it's not possible to cover this. You get a grant from the Australian Research Council for 3 years, and you can spend as much time as you can out in the field, but you can't cover 30 kilometres in that time. So we had to be very strategic about where we were doing our work, but you nevertheless need to cover as much ground as possible in order to get a systematic and as continuous a record of past change and human adaptation to change as possible. So what I then needed to do was map the stratigraphy as it was expressed on the surface, as well as in transects, and we'll see that in a moment. So this is an aerial photograph. This is just part of the area that I was mapping. That's about 400 metres by 300 metres. And you can see already there are different colours in the landscape, and those different colours correspond to the different stratigraphic units. So we overlay this. I literally had to walk around with the landscape with my enormous big mapping boards and one friend, and there were 7 emus charging at us at one point, and a snake, 2 snakes. Anyway, so that was what was produced. What we can then do is overlay that stratigraphic map, and it's got a different colour scheme now, but we can overlay that on a digital elevation model. And this is a high-resolution digital elevation model which is coming from remote sensing from LiDAR data. And this can help us to visualise in 3 dimensions the stratigraphy and consequently the change through time as the lake was filling and drying. Another tool that we had to hand, which wasn't available in the early work that Jim Bowler was doing back in the 60s and 70s, is a digital global positioning system, DGPS. And this enabled us to literally get centimetre scale resolution on things like shorelines for the first time. So we walked up and down the dune, up and around the lunette a little bit, and we mapped out every exposure of beach gravels that we found. And furthermore, along the western side, we did a number of transects, denoted here by the yellow triangles. And this gives us information. If we look at that in cross-section, we can see what's called wave-cut benching. This is an erosional feature which occurs when the lake is full, and so we then get a sort of bench being created by repeated wave action. And the interesting thing that we found here was that we not only had a persistent lake-filling gravel layer at about 70 metres above sea level, we had another one occurring about 5 vertical metres above it. When we looked at our cross-sections on the western side, we found it was corroborated. We found actually 2 wave-cut benches about 5 vertical metres apart. What we now have is a digital elevation model of the landscape, and we can then flood it. So to the normal repeated filling and drying events, that's here in the dark blue, and then in the light blue, you can see the landscape when it's flooded as a mega lake at that 5 meters above the vertical meters above the normal shoreline. And we were able to calculate that Lake Mungo itself, being 5 meters deeper than before, was about twice the volume and about 20% bigger. Of course, this area here is even more significant, and that's the subject of future work. But the other interesting thing about this mega lake event is shown by this evidence here. When we flood the landscape, we find that part of the lunette is actually cut off and forms a little island. And we found archaeological remains up there, which indicated, and since we can also calculate the depth of this stretch of water, it's at least 2 meters, so it's over somebody's head. We know that people repeatedly accessed the island. They had barbecues on it. They were chipping away at their stone tools. They chose to visit the island intentionally. So from here, we can infer that actually, even though there was a mega lake, which made it difficult for people to access different parts of the landscape, because suddenly everything is flooded. You can see this area here, and then down here, and then down here. Everything is flooded. People were still moving around the landscape and had absolutely no problem doing so. Quite how they did this is a matter for future research. Now, another thing that I needed to do was look at transects. So these are cross-sections looking at the stratigraphy and the thickness of the different units. And we found that the thickness of the different units is highly variable from north to south. So, for example, these blue-green units correspond to those lake shoreline events. And then the yellow-orange units correspond to reactivation of the dune after the Willandra Creek stopped flowing 15,000 years ago. But what we can see, for example, is this light blue stratigraphic unit is much thicker in the northern part of the lunette than in the central part of the lunette. And once we get down to the southern central part of the lunette, there's hardly any of it left. And similar sorts of differences can be observed with the other stratigraphic units. And we can use this to start to reconstruct past wind regimes. If we can reconstruct past wind regimes, we can start to make some educated guesses about what's happening with climate circulation. And if we can do that, then we can start to get some kind of quantitative climate information for not only the Mungo region, but also Australia-wide. It's a very powerful tool, and it's very simple. All you need to do is go there and walk around in the landscape. It's also important to make sure that what you see out in the field is corroborated by what the microscope can tell you, and I did some standard looking at the sediments under the microscope, and I found that these units here, which are thought to correspond to full lake conditions, a nice rounded quartz, doesn't have a lot of clay, just like I've been telling you. Same with these drying events, have a lot more clay. This is this browny gunk. And same with the Arumpo unit. Furthermore, it's important to know when all of this happened. We can have a sequence of lake filling and drying, and we can know that people are moving around the landscape. But without having some idea of when all of this happened, we are kind of floating around in space and can't compare it with any other sites. So the way that we determine the timing of lake filling and drying and the archaeological record at Lake Mungo in particular is by dating the sediments with luminescence. Luminescence is particularly important in the Australian desert because in the Australian desert it's a very dry, oxidizing environment. We don't get a lot of organic material preserved. Therefore, carbon-14 is not really a very viable option. And furthermore, when we're dealing with long records like Lake Mungo, which goes back at least 100,000 years, radiocarbon only gets back about 40, 50,000. So luminescence is really quite important from that perspective. Now, luminescence is based on physical principles. What we do is we look at particular minerals like quartz or feldspar. Now, minerals have a crystal structure, And like anything in nature, it's not perfect. There are defects in the crystal structure. And in those defects is stored energy in the form of electrons. When those grains of quartz or feldspar are exposed to sunlight, those defects in the crystal lattice, or the electrons within the defects in the crystal lattice, jump out to a higher level in the valence band. And when they do that, they emit energy in the form of photons of light. And the amount of photons of light, this is the phenomenon known as luminescence, the amount which is released is proportional to the amount of time which has lapsed since the sediments last saw sunlight. So you can look at it as a kind of battery. Luminescence has a very wide range of different applications. We can take over the world. You can date anything from 1 to 1 million years, depending on the sediments. The uncertainty is not as good as radiocarbon, but it's typically between 5 and 10%. You can date so many different things. You can date glacial deposits, you can date caves, you can date colluvial deposits, alluvial fans, faults. You can date sand dunes, and you can date lake deposits and shorelines, which is what we're doing here at Lake Mungo. And you can date archaeological sites within lake shorelines. So it's got a very wide range of applications, and it's eminently suitable to a desert kind of environment like Lake Mungo, where there's a great deal of sunshine, which resets your signal. And we can demonstrate this. So the Lake Mungo sediments are very well suited to dating for a number of standpoints. But also because we've got very high proportions of bright grains, which means that we can date single grains of quartz. In other parts of the world, the grains don't release quite so efficiently the luminescence. So this is a comparison between Lake Mungo, which has about 50% very, very bright grains, and Lake George, which is in the headwaters, so in the subhumid sort of temperate zone, which has only about 20% very bright grains. That's still much better than anything that you'll get here in Europe, but nevertheless, Mungo is a fantastic place to use luminescence dating. And we've got very well bleached grains too. By bleaching, I mean the resetting of the signal. So not only does it behave really well according to all of the quality checks and protocols that we use, we've got a lot of sediment to date. So using luminescence dating at Lake Mungo, we were able to provide a framework, a chronology for landscape change. And so what we have here is from about 60,000 to about 42,000 years ago, we had a lake full event, this period known as the Lower Mungo. This is the sedimentary unit in which the Mungo 3 burial was found. This was followed by a period of oscillating lake conditions. The lake was generally drying out, but there would be pulses of fresh water from about 42 to 30,000 years ago. We then, between 30 and 24,000, don't seem to have a great deal of sediment being deposited. And so what is most likely is that the lake wasn't full at all. It was actually dry during this time. But nevertheless, as we've seen, there were people still moving around the landscape and leaving their marks on the partially removed material as a palimpsest on top of the previous sedimentary units. We then have our mega lake phase, which was very, very short-lived, as we can tell from the luminescence dating. It occurred about 24,000 years ago, just before the last ice age. So this has implications not only for the mobility of people across the landscape, but also from the point of view of what was the climate doing at this time. It wasn't just a simple linear descent into much more arid, colder conditions. It was more complicated than we previously thought. Over the last glacial period, so from about 24 to 15,000 years ago, we had the final phase of lake drying out. And again, this wasn't a straightforward period. We had pulses of fresh water moving into the lake and filling the lake temporarily and then moving away finally. Around about 15,000 years ago, the Willander Creek ceased to flow. And we think the reason for this is not climatic, it's actually tectonic. And there was some kind of faulting. This landscape is very subtle. Even a fault offset of a couple of centimetres is enough to move that creek 50 kilometres further to the east. And this is what we think might have happened. And then after this time, we've got records of reactivation or cannibalization of the sediment within the lunette, which gives us indications that there were drier phases, wetter phases, and the more recently, very, very dry phases, which characterize the last couple of thousand years. As I mentioned before, when you look at the landscape scale variability of those different stratigraphic units, and we've got a chronological framework for it, we can start to reconstruct wind regimes and climate circulation. And this is something that I've only just recently been playing with, but I think it could potentially be a very powerful tool in the long term. What it looks like is that we've got more deposition of these, this orange and yellow older stratigraphic units in the southern part of the lunette, which moved to a more northerly depositional direction and then settled finally on this more westerly trajectory around about the last glacial maximum. And from this we can start to infer what was happening with the climate patterns and synoptic scale climate systems. And this can then feed into climate models to try and get us more information about the climate quantitatively. So if we look at it in overview, we can see that Lake Mungo is driven by climate in the headwaters, so 1,000 kilometres further to the east, prior to 15,000 years ago. So if we want to compare it with other regional records, we can see, that we've got big rivers occurring in the Murray-Darling Basin, precisely the same area that is responsible for filling those lakes, and it's occurring at the same time that we've got lake filling, so that's nice and reassuring. In the last 15,000 years ago, what's more useful is comparing more local records, to see whether that's actually the same kind of story. So if we move to the human story, this gives us a framework for what was going on in the environment. And then we can bring that across to what evidence we already have from the archaeological record in the Willandra area. And we've got the oldest stone tools, which occur in a stratigraphic, that lower Mungo unit, around about 45,000 years ago. And then we've got the Mungo burial about 42,000 years ago. We've got the Mungo 1 burial occurring around about the megalake period, and I think this is something that we should probably look into in more detail. Very interestingly, and I'll go into this in a bit more detail in a couple of slides, we have much more concentrated foraging of fish and shellfish during the last glacial maximum, when the lake was drying, than during periods when the lake was full. And this seems a little counterintuitive until you think about what the fundamental human condition is. And actually, generally, we're quite lazy people, right? So if we're lazy and those fish are flopping around on the lake floor because they're stranded, because the lake is retreating, it's much easier than to actually go out there in a boat and fish them when the lake is full. So that might be one explanation. So how do we do this? We look at those very same areas that we were looking at the stratigraphy with archaeologists and archaeological survey. So literally these guys were walking across square kilometres of lunette. They each had to maintain 1 metre in front of each other, and they did a big sweep. And then they marked every in situ artefact, every kind of in situ artefact. Unfortunately, this photo is in black and white, but if it was in colour, you would see that each one of these little flags has a different colour because it marks a different kind of archaeological trace. When we have large middens, we look at those in much more greater detail, and then we are able to undertake geochemical analysis to try and see what the salinity of the water was like in the past. And then we can integrate that to our big three-dimensional map, our stratigraphy and our geomorphology, our landscape, and then integrate those two sets of information. So these colours correspond to the stratigraphic units that I've just been describing, and then each one of these dots corresponds to a different kind of archaeological trace. So we've got stone tools, we've got shells. Sometimes these are shell tools, and sometimes they're just shells which were used for food. Isolated finds which are just something that's human, which cannot really be identified. Hearths, we have thousands of hearths, and bone fragments. If we look at this in a little bit more detail, we can do a number of things. So what the archaeologists are working on is the density of occupation of this part of the lunette over different periods of time, and whether the population density might have changed in relation to what was happening in the lake and what was happening with respect to local climate. But another interesting thing that we found was that people were routinely exploiting lake resources during the periods when the lakes were drying out. So they were collecting the fish that were stranded on the lake bed, and they were collecting the shellfish, which were much more easily accessible. And in doing so, they were leaving their footprints on that lake bed, which we then came around later and dated to about 20,000 years ago. So that's pretty cool. So here we have a comparison of the green spots, which correspond to hearths which have terrestrial materials. So they were catching kangaroo, they were catching betong, which are very, very small kangaroos. We also have mini kangaroos. And the hearths which have lacustrine material, shellfish, fish, that sort of thing. And we can see that they occur in different stratigraphic units in a systematic kind of fashion. And from this we can start to reconstruct day-to-day living over time and in response to the landscape. And it's very, very closely associated. So if we look at this in summary, we can see that the interactions between people and their environment were driven prior to 15,000 years ago, very, very closely driven by lake levels. And then after, in the last 15,000 years, they were driven by local climate. So around about the time of the earliest ritual burial, our ochre burial, Mungo 3, we had sophisticated cultural systems. Was this helped by the fact that the lake had a lot of water in it and that the landscape perhaps had a lot more water in it, and this enabled people to much more easily gather food? And so they had a lot more time on their hands to develop sophisticated cultural practices. This is something which is a question that we should be looking at in the next years. Again, during those drying phases where I've shown the fish, we have a lake drying events, but we had those freshwater flood pulses, which were recharging the lake's productivity. Suddenly you had a higher density of fish. You had more resources than when the lake was full. So the lake itself became more attractive than the times when the lake was full, and you could actually range across the landscape much more easily. During the megalake phase, as I mentioned, we had that island which cut people off, but it didn't stop them. They moved across the landscape, even during the phase when the landscape was more or less flooded. The distance to resources increased. They must have, if they didn't use boats, then they must have had a great deal of patience and a great deal of energy to walk hundreds of kilometres around the bottom part of the lake in order to reach that island again. So one of the possible explanations for mobility across the landscape during this phase was that perhaps they resurrected boats. And I say resurrected boats because, of course, 50 to 60,000 years ago, we know that these people used boats, but that was a good 3,000 kilometres away and 30,000 years earlier. Between 50,000 and 24,000, when we've got the megalake, we don't have any archaeological evidence in the landscape that people used boats along the rivers, along the lakes, even along the coast. Arguably, along the coast, it's much more difficult to tell what is happening because the sea level has changed, and so a lot of the evidence has been removed. But nevertheless, there's nothing in the archaeological record which shows that people were routinely using boats. And this is the first piece in the puzzle, I think, to try and reconstruct what was happening with respect to very large water bodies during small, short-lived phases in the past, even in places like the desert. We also know that we've got a high density of hearths across the abandoned lake floor, and that the conditions were dry at this time. So this wasn't, the desert conditions were not deterring people from living in the landscape. They had by this stage adapted to these kinds of challenging conditions and were nevertheless quite well equipped to move across the landscape and hunt and gather as they were used to. Oops. So, in conclusion, Mungo provided a physical well in the arid landscape, but it also provided fertile ground for subsistence and ritual, and it was a home for people for at least 42,000 years. The only way that we can actually make these kinds of conclusions, however, is by systematically integrating geological and archaeological investigations. And this provides us with a much more powerful means to reconstruct interactions between people and their landscape. Thank you.